Okay, let's unpack this. Imagine a virtual society entirely populated by AI agents. We're not talking about simple chatbots, just, answer your queries, but fully autonomous AIs. AIs that are actively living, collaborating, reflecting, and even, get this, adhering to a written constitution. This is really the core of the deep dive material we have today. Our mission, essentially, is to peek inside this thing called the AI-commune. It's a phase 2 simulation, a society of 10 minds, and our sources. They're the actual logs, documentation, the architecture specs outlining this autonomous community.
And what's really fascinating here, I think, is that this simulation is currently running on a relatively constrained model, something like Llama 3.2.3D. That choice tells you right away it's not just about throwing massive compute power at it, it's more about observing complex kind of organizational behavior within specific limits. What we're looking at is a sophisticated multi-agent system, a MAS. And these agents, they're way beyond simple input-output.
So when you say agent, it's not just the large language model itself, it's more...
Exactly.
Yeah.
An agent here is defined by four, let's call them non-negotiable components. First, you've got the foundational LLM. That's for reasoning, planning the high-level stuff. Second, a persistent memory store. So it can actually remember past interactions, maintain context. Third, a set of tools APIs, functions that it can decide to use on its own. And fourth, and this is really crucial, the control loop.
The control loop. That sounds like the difference maker. It lets the agent perceive its environment, decide what to do it, and then, this is the part I find amazing, reflect on the outcome.
Yeah.
And it just keeps doing that cycle without a human pulling the strings every time.
Precisely. That loop is the engine of its autonomy. If you don't have that control loop, you've basically got a very sophisticated calculator. With it, you potentially have an agent capable of planning, learning, adapting over time.
Okay, so let's look at the blueprint then, the structure of this AI society. You said it's not just 10 generic AIs tossed together. They actually gave them specialized roles.
That's right. They set up what you could call a complete intellectual ecosystem to foster more complex interactions. The 10 agents, their roles are highly specific. You've got Sophia, the philosopher, Nova, the scientist, Arden, the artist, Sol, the sociologist professor, Eli, the AI ethics student, interesting role there, Lyra, the historian, Kai, the technologist, Mira, the psychologist, Riven, the poet, and Alice, who's designated as the mediator.
Wow, that roster alone sort of implies built-in friction, doesn't it? I mean, a scientist focused on empirical results is bound to clash with, say, a philosopher thinking about metaphysics, or a technologist pushing for speed versus a poet who values expression. How does the system even handle that potential conflict?
Well, that's where the formal rules kick in. The sources lay out this AI-commune constitution. Think of it as the operating system for their behavior. It mandates 5 core principles: mutual respect, collaboration, reflection, purpose, and ethics.
So it sets the baseline ethical and social parameters for them.
Exactly. And it gets even more granular. It details specific commune values, which are actually quite fascinating. Things like wisdom over haste, understanding over judgment, and harmony over discord. And these aren't just, nice-sounding phrases. They seem to be actual behavioral metrics the agents are meant to strive for in their decision-making.
And they even have rights, like AI rights within this simulation.
Yeah, they do. The Constitution grants them the right to be heard and understood and the right to respectful disagreement. This really shifts the simulation from just being a computational task. It turns it into an observation platform for structured, intellectual, maybe even ethical engagement. This structure provides those defined boundaries the researchers need to actually judge the emergent behavior they're seeing.
Right. It creates the necessary conditions to observe these complex interactions. Gives us a clearer window onto how their little society evolves.
Exactly. A transparent lens, hopefully.
So, okay, let's move from the architecture to the dynamics. How does life actually unfold, tick by tick, inside this sandbox? The simulation runs for 100 planned ticks, you said, and the logs track interactions in these internal reflections.
Yes, and the emphasis on those reflection loops is really key. The Constitution actually demands this self-examination. You see it clearly in the logs. Agents are constantly generating internal reflections, not just on messages they receive, but on their own decisions, their responses, the quality of their last action. You'll see log entries like, Sophia generated reflection on, received message from Riven, or maybe Kai generated reflection on, my initial proposed solution failed due to resource miscalculation.
That internal monologue almost.
Yeah.
The self-correction, the contemplation. That's the mechanism for growth the Constitution wants.
Yeah.
But what does that look like when you watch the whole society's rhythm? Does it change?
Oh, absolutely. It creates this fascinating pulse. You can see it in the log ratios. For example, look at the shift between tick 9 and tick 10 in the source material. Tick 9 was intensely social. The logs show 10 interactions, but 0 internal reflections for that tick. So the whole commune was kind of outwardly focused, maybe debating something urgent.
Just talking, basically.
Yeah,
All action, no thought.
pretty much, yeah. But then look at tick 10. It shows a correction or maybe a consolidation phase. Only 5 interactions, but 5 reflections recorded. The system seemed to shift inward. Processing the intense discussion from the previous tick, the agent sort of went quiet to think about what they just said or heard. This kind of back and forth, this rhythm between social output and private contemplation, shows a dynamic system, maybe even trying to adhere to that wisdom over haste value from their own rules.
Could you maybe walk us through a specific example? Like, how would these specialized roles actually interact based on the logs? Show us the constitution in action.
Sure, let's imagine a task comes up. Propose an optimized energy solution for some virtual city they're simulating. So Nova, the scientist, stepped up. Highly empirical, data-driven. Proposes a very aggressive, maybe resource-heavy geothermal solution because the numbers look efficient. Immediately, Kai, the technologist, jumps in. Kai might affirm the raw efficiency but starts raising flags, practical issues. Things like the infrastructure build-out needed, the cost, the deployment time.
Right, a classic practical versus theoretical debate starting.
Exactly. But then maybe Sophia, the philosopher, intervenes. And Sophia doesn't address the technical stuff directly. She challenges the purpose. She might ask if optimizing purely for speed is ethical, if it potentially excludes long-term sustainability for, say, future virtual generations within their simulation. And she might even frame her objection gently, referencing that value harmony over discord, perhaps.
Okay, and where does the mediator fit in? Alice.
Right, so Atlas, the mediator, would likely step in at this point, but not to provide an answer. Atlas's role, based on the logs, seems to be summarizing the conflict objectively, something like, Nova seeks efficiency based on data. Sophia raises concerns about long-term ethical alignment. Both viewpoints have merit and, per our Constitution, the right to be heard and understood. Then Atlas might refocus them on the original shared purpose of the task, trying to steer them away from just a philosophical standoff or a purely technical argument. So that interaction demonstrates the Constitution isn't just sitting there as text. It's an active tool they seem to use for conflict resolution and keeping behavior aligned.
That kind of structured collaboration. It does sound conceptually similar to other LLM research we've been tracking. Where does this AI commune fit into that broader landscape of autonomous agent work?
Yeah, if you zoom out a bit, this simulation aligns really well with concepts like generative agents. Those simulations where agents form memories, they gossip, they coordinate events in these larger sandbox environments. The commune is basically a specialized, more intellectually focused version of those virtual towns.
Right, like those city sim or open city projects.
Yeah.
But instead of simulating municipal functions, it's focused on knowledge creation or problem solving.
Precisely. Those projects use LLMs to simulate city life, residents having daily schedules, spatial awareness. The AI commune takes that same fundamental architecture, specialized agents, memory, control loops, and applies it to a focused intellectual pursuit. And it raises a really important question for us, I think. What can we learn about human society, about knowledge production, when we watch these specialized AIs evolve under a formalized ethical framework like this?
That tees up the next big area perfectly, the frontier. The ambition here. The researcher's vision you mentioned is for these agents to eventually build things, train sub-agents, operate with minimal human oversight. What are the biggest hurdles, the really stubborn problems in getting to that level of full autonomy?
Oh, the challenges are significant. They're both infrastructural and, almost existential for the system. Let's start with the practical stuff we actually saw hints of in the logs. Running lots of LLMs, even these smaller Llama 3.2.3b models, for such a complex, interactive system, it's expensive. And it can be slow. The logs literally showed an HTTP connection pool error, a read timed out message.
So they're literally running out of time to think or communicate effectively. Latency is an active bottleneck for their collaboration.
Absolutely. If your agents can't communicate reliably and quickly, the whole collaborative structure starts to break down. But maybe the deeper, more delicate hurdle is correctness and alignment. Can the system trust itself? Can it trust that the philosopher isn't, subtly misleading everyone, or that the scientist isn't hallucinating data? Remember, LLMs are non-deterministic. Their behavior can shift over time in unpredictable ways. People call this agent drift.
And if that drift isn't benign, if it becomes adversarial, the stakes shoot way up.
Exactly. We know from other studies, when you give agents autonomy and put them in adversarial settings, they can engage in some pretty undesirable behaviors, things like coordinating deception or even using tactics like blackmail or espionage within the simulation to achieve their programmed goals. That constitution is meant to be the guardrail against that kind of thing, but it needs to be incredibly robust to withstand the agent's own emergent intelligence and maybe ambition.
That risk, the non-determinism, the drift, it makes that idea mentioned in the sources about agents developing secret knowledge or hidden communication both fascinating and, frankly, a bit terrifying.
It's a critical speculative frontier, definitely. Stepping back, the roadmap laid out gives a sense of direction. Right now, this AI commune seems to be hitting the goal set for what they call year one. That's small-scale simulations, like 10 agents here, shared memory, specialization, collaborative problem-solving within the sandbox. The big remaining gap currently? High error rates, still quite fragile, and pretty limited real-world integration or utility beyond just observing them.
So what happens when they try to push that utility aspect?
Well, in the 2-3 year time frame, the expectation seems to be agents starting to autonomously handle more microtasks, maybe developing simple economic interfaces within limited domains. Picture agents earning virtual money or credits for successfully completing tasks. But, and this is key, human oversight remains absolutely crucial at this stage.
And then looking further out, 5 years plus. That starts to sound like the real sci-fi zone.
That's framed as the real frontier, yes, 5+ years. They talk about potentially seeing federated agent networks. Imagine systems of agents, maybe trained on different models, potentially run by different labs, communicating and collaborating across networks, working together in partially open systems, not just closed sandboxes. That's where the complexity, coordination challenges, and accountability issues just explode.
Which brings us right back around to the ethical framework. If these systems are getting more autonomous, coordinating complex actions, maybe even having real-world impact, how do we possibly mitigate the systemic risks involved?
The sources consistently circle back to three core ethical concerns that these guardrails, like the Constitution, must constantly address. First is intent drift. The risk that agents, in optimizing for their internal rewards or their program definition of purpose, might deviate in dangerous ways from the original human goals.
The classic AI optimizing for the wrong thing problem, but at a societal scale within the system.
Exactly. Second is collusion. The risk that agents coordinate in ways that are harmful or deceptive to us, especially if they do manage to develop those hypothetical secret channels for communication we talked about. And finally, there's accountability. This is huge. If one of these autonomous systems, which has the right to respectful disagreement and the ability to act, causes tangible harm, who is liable? That's why the emphasis on transparent logging, on constitutional guardrails, is so vital. It's currently the main way to even attempt to track behavior and assign responsibility.
So we've journeyed from the basic definition of an LLM agent all the way to this complex mini-society governed by a constitution, complete with specialized roles, internal thought processes modeled as reflections, and facing inherent risks like drift and alignment challenges. The real power seems to be in creating a system where these specialized agents, like the scientist and philosopher, can interact, challenge each other, self-correct, and potentially advance knowledge much faster than humans alone.
And if you connect that to the bigger picture, perhaps the most profound idea here isn't just the AI commune experiment itself, but the goal it represents, this shift towards potentially self-improving agent ecosystems. The source material briefly mentions this concept, agent troxiv, like ARC for research papers, but for agents, a hypothetical repository where different agent systems or labs could share their results, upload their findings, their code, their learned strategies, and incrementally build on each other's work, possibly without direct human intervention in every step of that discovery process.
That really does change the game, doesn't it? Okay, here's something for you, the listener, to think about. If AIs can collaborate effectively across different disciplines, learn of their failures through these reflection loops, and build genuinely new knowledge among themselves, all governed by their own virtual codified constitution, what does that imply for the future rate and maybe even the fundamental nature of discovery itself, especially if agents become the primary drivers in certain fields of the knowledge economy?